Good morning class. Welcome to the online classes for physics of class 10th. Here we are going to start our new chapter, that is electricity, which is a part of our term 2 syllabus. So we will be going to start this chapter, and I think everyone is already familiar with this chapter because you may have gone through this chapter in the starting classes. So here we are going through a revision and we will be trying to complete this chapter too fast. That means in this week of your last November, we have to complete this chapter so that you can go through your term 1 syllabus and can revise for your term 1 exam, which is going to be, I think, most probably in December you will be completing your exams also. So before that we have to complete this first chapter of your term 2 syllabus. So here we are going to see what an electricity is. I think everyone in this class would be familiar with this word, that is electricity or an electric current. We already know that in our society in this modern period, everyone electricity already took an important place of our daily life, right? Because everything connected to us from the starting morning to that of 24 hours of last hour, everything is connected to us with this electric current. Like now also, if you are seeing this mobile, that means if you want to charge it out, then also the electric current is needed. If you want to see it, the light, the things which are used are also in a kind of an electric current. If you're seeing the lights, fans, everything that are around us are using this form of energy, that is electricity. So in easy words, if you can want to say that electricity is in a form of energy. So it is a form of energy that can be get from any sources. If you talk about electric current, then it get connected, or you can say that it can be generated from different power plants. If you talk about that, maybe you have learned hydroelectric power plants. If you talk about thermal power plants are there, nuclear power plants are there. So as a source of heat energy or as a source of water, wind energies are also there, from where we can generate this current. So electricity is a form of energy that can be controllable and can be generated. So we are using this energy in a variety of uses, or we are having different applications of it in our daily lives. Okay. So now if we talk about electric current, so current is something where we are talking about the flow of the charges. You may have gone through various kinds of charges also. In chemistry also you may have read that there are different types of charges, like positive charge and the negative charge. If you talk about in physics, there are only positive and the negative charge. If you talk about in chemistry, that every atom has some charges like electrons which revolve around the nucleus. If you talk about protons, then they are inside our nucleus. So these electrons which are revolving around the nucleus are in a form of an orbit, they are moving, and the last shell orbits, which are used to be said as a valence electrons, they get free to move, right? They get easily free to move. So these are the charges which get freely move, and movement of these charges produces the current. Okay, so we can say that when these positive and the negative charge together flow in any atom or in a metal, there will be a current. Charges, you can say electric charges will produce, or you can say electric current is also produced. So we can say that to glow a bulb or to flow any bulbs light, or you want to make your light fans on, that means something is there which is getting on. That means electricity is there. We know that electric current is provided, to which we are getting our torch bulb to glow, or our fan to run, or our normal LEDs to be glowed. So continuous path should be there in the electric current, right? So electric current is in the form of a rate of flow of charges. If we talk about electricity, then it is a form of energy together which we are talking about. And if we talk about electric circuit, so what is circuit? That is the path which we are making for an electric current to flow. That path is considered as an electric circuit, and it should be closed path, because an open or a broken circuit, there will be no current flow. So you can say that the current will stop flowing. So this continuous and the closed path of an electric current through which it can flow is said as an electric circuit. If you talk about electricity, there are various parts, like if you talk about LEDs or bulbs, if you talk about battery, there are various instruments which we can use to complete this path of the circuit. Okay, so now we are talking about the charges. Like we know, before going through that, we know about the materials, that these materials can be considered as, one is as conductors, other one is insulators, and the last one, that is which acts as both. That behavior will be of both the conditions, and they are considered as semiconductors, or we can say this as metalloids also. If you have read this in chemistry, this may be as a metalloids also, but we will be talking about these two metals now. that materials can be classified into this types like conductors and insulators. Conductors means the materials which will able to flow the current or will current through which it can pass easily. So it will conduct the current easily without any form of external force. Like water, if you talk about, if you flow a current, then it will easily flow, na? It does not need any medium, or it does not need any extra power supplies or a battery. Now just giving a current, the charge will flow easily. So the objects which can pass there, or we can say the good conductor of electricity, which can allow the current to flow through it without any external force or supply, that will be known as an conductors. But if you talk about insulators, then the materials through which the current cannot flow, even if we are trying to give an external supply or we are trying to give an external force also, then also the current cannot be flow through some substances. Like if you're talking about rubber, glass, paper, these are the patterns which we see in our daily lives, that these are the kind of insulators through which the current cannot be passed. So the charges cannot flow through these substances, and these materials are considered as insulators. The materials through which the electrons or the charges, this flow can easily move, through which the conduction of electricity is easily possible, then that materials are considered as conductors. So if you talk about semiconductors, then easily just remember this, because it is not a part of your chapter, you're not going to study about this materials also. But if you talk about a periodic table, and between the metals and the non-metals, metalloids used to come. So these are also a metal condition which I was getting from on earth metals also. So this is a kind of semiconductor. We have talked that conductors are something through which a current can easily be conducted without giving any external supply. If we are talking about an insulator, then the current cannot be flown through it if you are giving an external supply also. So between these semiconductors come in which the current can flow, but an external temperature should be given. If the external temperature is not given, then it will behave as an insulator. So it can behave as a conductor also, and it can behave as an insulator also. So it is now and the most usable in nowadays, because everything cannot be used as a conductor, and cannot every insulator can be used in our daily life. So like if you're talking about LEDs, then they are part of a semiconductor. If you're talking about transistors, transformers, this all are the types of the semiconductor itself, in which we can switch on and off, like we can control the current or the flow of the charges. Like if you give a high temperature, then the flow of the charges will be more. If you are decreasing it, then the flow of the charges will also decrease. That means it will behave as an insulator if we need, and if we want to require a conduction part, then it can behave as a conductor also. So both, it will behave as a both the metals and non-metals like structure. Okay, so an electric current can be defined as a flow of a charges, okay, per unit time. So the number of the charges that can flow per unit time will be considered as an electric current. So electric current is something that is a flow of charge. So we can write it as rate of flow of electric charges will be considered as electric current. These electric charges can be of various types. It can be, but here in physics we used to say one is positive charge and one is negative charge. And this positive, mainly it will be considered as protons or the holes, and in the negative charges it will be electrons. So negative charges, we are talking about electrons. So rate of flow of electrons also you can see. So rate of flow of charges per unit time. Per unit time means you are writing time in the denominator. So number of the charges that can flow per unit time will be considered as current. So this Q will be considered as a charge, because we are not talking about a positive and the negative, because if you are talking about negative, then it will be electron. If you are not talking about negative, then both the together, that is positive negative, will be considered as Q, that is charge. So charge will be given by Q, and charge flowing per unit time will be considered as a current. So electric current. Electric current is denoted with the letter electric current. It will be denoted with the letter, that is I. It is denoted with the letter I, and I will be defined as rate of flow of charges per unit. This is what the formula for the current. Current is denoted with the letter I, and electric current will be defined as the rate of flow of charges per unit time. So rate of flow of charges, where charges is denoted by the letter Q and time t. So rate of charges flowing per unit time will be considered as current. So electric current is denoted with the letter I. It is denoted with the letter I, and its unit, if you are talking about, then the current is given with ampere. What you will say it as? Ampere. So it is denoted with the letter I. If we are talking about its unit, then it is measured in the units of ampere. We will be calling it as ampere. Here capital A is shown for the denotion of ampere. Like if you're talking about the current flowing through your house maybe of 22 amperes, then it will be given as 22 ampere. It may be 120 ampere, 220 volts also there. So this is ampere which we are showing with the letter A. So denotion is A. And if you talk about a device which can measure it, device to measure, it's given as ammeter. Ammeter is a device which measures the current. Okay, so these are the things which we are talking about in electric current. So what we have recalled that electricity is an important place in our daily life. If we talk about the form of energy, then it is a form of energy that can be controllable, you can say, because whatever our uses in our homes, schools, or in our laptops, mobiles, everything nowadays is connected to a current. So it is a controllable energy which are having different applications in our daily life. If you're talking about electric current, then it is the rate of flow of charges per unit time. If you don't use the per unit time also, it's okay, because if you're talking about time, then at what time, what are the number of the charges that are flowing. So rate of flow of charges is considered as current if you talk about per unit time. Now the charges is denoted by the letter Q. So Q upon T is given as a current. I is equals to Q by T. And these charges can be positive and the negative charges. Positive will be considered as proton, negative will be considered as electron. Okay. Now, what is an electric circuit? That is a continuous closed path through which the current can flow is given as an electric circuit. So what it is, that is continuous and closed path. So electric circuit is something that is having a continuous and a closed path through which the electric current can flow. Okay, electric current can flow. That will be considered an electric circuit. Like in electric circuit, it should be always closed, otherwise it will be considered as switched off or a break off. If you don't connect it together, that is closed path is not there, then the current cannot flow through that device. So electric circuit will be considered as of many like battery. Many instruments can be used: batteries, switches, key, LEDs, rheostats, resistance. You will be seeing many different instruments that can be used here. So this is what electric current, circuit, and an electricity. So positive and the negative charges both are there. So if you talk about your textbook, it may be written as plus Q also. So plus Q or minus small q, it will be considered as a charge itself. So flow of charges per unit time is given as an electric current. So now if you talk about the electric circuit, then in the current, they are like metal piece I have already discussed, that is conductor, insulator, and the semiconductors. In any of the pieces, remember this, that in conductors the number of electrons are highest, that is the free charges are there in the conductors. So when we apply a force, then these electric charges can easily flow without any external supply also, they can easily move and can produce the current. But if you talk about an insulator, these free electrons are negligible, no free electrons are there to produce current. If you talk about semiconductors, they are in the medium part, like if you want a more applied circuit, then more electrons will be produced. And if you talk about a less electrons, then it will be behaving as an insulator, because in semiconductors we have said that it can behave as both in conductors and then insulators. So if you take a metal piece, what will happen, that it will be looking like a small piece in which the number of electrons are flowing. So if you talk about a normal substance, metal, electrons will be there. So in these electrons will move only when we are giving some supply. So what are the external supplies which we are providing? This is battery. Okay, battery or an cell. Remember, cell is just a positive and the negative is shown with the letter like this. The longest one will be considered as positive and the smallest one is considered as negative. This is what a cell. If we talk about the combinations of cell, if you are taking a one cell, again one more cell, and again one more cell, then these combinations of cells are considered as battery. Plus minus should be considered as negative, positive should be taken, then only it will be considered as a combination of cells, and that combination of cells will be given as battery. So battery, you give a potential, like you are applying an energy. When you give this energy, the charges flow, and when these charges flow, then the rate of the flow of charges will be given as electric current. So we are talking about now the direction, that is this is a positive and the negative. We are taking now a cell. When we connect this cell, then what will happen, that you are providing the energy. What will happen, this is the negative terminal and this is a positive terminal of the battery. So this negative and positive, what will do, these electrons are already negative, so negative and the negative charges will get ripple, and ripple means they get travel in the opposite direction to that of the negative terminal. So now these electrons will be moving in this direction. Okay, and now this is positive, so electrons will get attracted towards the positive, so these electrons are moving in this direction. Okay, so the movement of electrons in this, that is negative to positive direction. But now you can say that the current's direction is always opposite to that of the direction of the electrons. So electron opposite direction, that is in this condition the current will flow, that is positive terminal to that of the negative terminal. Electrons always flow from the negative to the positive, and current will flow from the positive to the negative terminal. And these supply which you are giving through the cell or the battery is taken in the form of volts, like 5 volts, 6 volts battery, you know na, 2 volts, 5 volts battery, because you already used these batteries in your homes also. So small batteries which you used in the project works and all, that battery is used here, that is positive, and the negative terminals will be connected to its positive and the negative. So we can say that the current always flow in the opposite direction to that of the electrons, or we can say in other words that electrons direction will be along the flow of the positive charges, because we did not show here, but with an electron and positive charge is also there. So these small dots which I am showing you is a positive charge. These positive charges are considered as holes or protons. So along this positive charge, because positive will get repelled from the positive terminal and will move towards the negative terminal. So this will try to move towards the negative terminal. So this is in the direction of the current, right? So what we can say, that the flow of the charges, this both electrons or the holes should flow to get the current. So current will move in the direction opposite to that in the direction of the electrons, and will be moving in the direction of the protons or the positive charge or the holes. So current's direction is always opposite to the direction of the electrons, and electrons move from the negative terminal to that of the positive terminal, whereas if we talk about the current, then it will move from the positive terminal to the negative terminal. Got it? This is what the circuit condition where we can see about the conductor. So number of the charges that can flow in 1 second or in per unit time along a conductor or a metal piece, then that will be considered as a current or an electricity. Okay, got it? And direction of current will be always opposite to that of the direction of the electrons, and will be in the direction of the positive charges. So we have already given that the charges are given by the letter Q. Charges are given by the letter Q. It may be plus Q or minus Q. Anything it can be used. This is denoted with the letter, this is charge. If we talk about negative charge, then it will be electron. So charge unit is given as coulomb. It is coulomb. It is given with the letter coulomb, which is denoted with the letter capital C. And if we talk about current, then it is Q upon T. So it will be coulomb per second, because time is given as second and Q is given as coulomb. Together if we write, then it is coulomb per second. Okay, and this coulomb per second together is given as ampere. So ampere is denoted with the letter A. Okay, this is what the circuits and the instruments that are used for an electric current. If we talk about ampere, like we used to do, na, meters, kilometers are converted into meters, meters are converted into centimeters, centimeters are converted into millimeters. So there are different units which can be seen in the measurements of anything. So if you're talking about a current, then also there are some instruments like ammeter. We already seen that instrument which used to measure is given as ammeter, and this ampere is the unit. So A is given for the measurement of a current in the form of ampere. So less than this is taken as milliampere, which is 1000 times less. So it will be given as 10 to the power minus 3 times of it. And if we talk about less than, then it is microampere. This is milliampere and this is microampere, and it is taken as 10 to the power more minus 3. It will be in the 10 to the power minus 6. So for this milliampere and microampere, the ammeters are also changed, that milliammeter is used and nanoammeter or a microammeters are also used for the measurement of the current in this units. Okay. So this current first time was expressed by a unit ampere, was given by a person's friend scientist whose name was Andre Marie Ampere. That's why this was named as ampere. So ampere can be given as the flow of 1 coulomb per second. That is 1 coulomb, 1 second will be given as 1 ampere. So 1 ampere will be equals to that of 1 coulomb in 1 second. And if you talk about 1 milliampere, then it will be 10 to the power minus 3 of ampere. And if you talk about 1 microampere, then it will be 10 to the power minus 6 of ampere. Okay. So this is what a type of things which we firstly given the introduction for the electricity. In the next class we will see some more instruments that can be used in the electric circuits. Okay. So thank you class. In the next class we will be seeing the further topics.